Good afternoon. Good afternoon. Please welcome Dr. Tangela Alford-Gentles, President of Theta Mu Omega.
Good afternoon, everyone. Again, I am Dr. Tangela Alford-Gentles, President of the Theta Mu Omega chapter of Alpha Kappa Alpha Sorority Incorporated. Welcome to today's webinar. We have left 2020 behind and welcomed 2021 with a new sense of hope. That hope is possibly because of the vaccine. Our chapter is dedicated to advancing knowledge and the understanding of the COVID-19 vaccine. We launched this series to provide insight into the status of the vaccine and shed light on uncertainties and facts. We have worked hard to ensure that you receive information from professionals and you will hear from leading experts that will address concerns and questions on the approval and use of the COVID-19 vaccines. If you needed more information before deciding, you are in the right place. And remember to sign on for the other 2 webinars in this series. Thank you to Dr. Samira Bowen and her committee for planning such a wonderful series, and thank all of you for joining us today.
Thank you, Dr. Alford-Gentles. Please welcome Dr. Biddle Richard, who will introduce our moderator for the day.
Good afternoon. Dr. Valencia P. Walker has garnered a national reputation for her justice, equity, diversity, and inclusion efforts within medicine, science, and healthcare. As a practicing neonatologist, she champions the elimination of health inequities with a focus on Black maternal and infant mortality. Dr. Walker recently joined Nationwide Children's Hospital in the role of Associate Chief Diversity and Health Equity Officer. Prior to this, she served as an Assistant Dean of Equity and Diversity Inclusion for the David Geffen School of Medicine at UCLA. A physician leader, Dr. Walker chairs the California Medical Association's Council on Legislation and provides guidance on the legislative activity for the nearly 50,000 members represented by the organization. She also previously served as president of the Association of Black Women Physicians, a nonprofit organization dedicated to diversifying the physician workforce, advocating for historically marginalized communities, and promoting health equity. At the national level, she is the program chair for the American Academy of Pediatrics section on minority health equity and inclusion. Dr. Walker graduated from Florida A&M University, where she was initiated in the Beta Alpha chapter of the Alpha Kappa Alpha Sorority Incorporated. Dr. Walker received her medical degree from Emory University School of Medicine. After completing her pediatrics residency at UT Memphis, she went on to finish a neonatology fellowship at Cincinnati's Children's Hospital's Medical Center. Dr. Walker also obtained an MPH in health policy from Harvard T.H. Chan School of Public Health. Welcome, Dr. Walker.
Okay, good afternoon, everyone. It never gets easier to listen to other people talk about you. So let's move on from me and get to why we are here today. Thank you so much to everyone that has joined us. I have the pleasure of introducing our speaker. And we're going to start off today by providing with some knowledge and some background, and then we'll open up to a panel. We've received so many questions from a lot of people before we even got on this webinar. And I want to do my best to get to as many of those questions as possible, as well as giving our panelists a chance to really speak to their expertise as well. But first, let me start off with an introduction of our guest speaker. Dr. Ogadima Obi, known as Dr. Oga, is a native Houston Texan. She received her MD from the University of Texas Medical Branch, and she graduated with honors. And she did burn research to obtain those honors. Right now, she is a board certified emergency medicine physician, and she's a part of a thriving emergency medicine group in El Paso, Texas. In addition to that, Dr. Olga is a cannabinoologist, and she provides care throughout Texas, California, and Louisiana. Now, one of the things that I think she wants you to understand about her is that she is an advocate for health innovation. She's not someone who's just going to open a textbook, read it to you, and tell you this is what we're going to do. And she's very passionate about making sure people are healthy and that we do things to prevent you from getting sick. She has an herbal apothecary in Houston's 2nd Ward District, so I hope we have plenty of Texas folks and Houston folks representing for her today. And she's available after this if you want to bring her in to talk to you more about all of this amazing and exciting work that we're doing to help make our community healthier. So at this point, I'd like to turn it over to Dr. Olga. Thank you.
Thank you, Dr. Walker. And I want to thank everyone for having me. I am honored to be here today to talk to you all about a topic I'm very passionate about. This topic is called Tuskegee syndrome. And what I want you all to understand is innovation for our communities comes from our past. It comes from our experiences. It comes from our pain. It comes from our fear. It comes from our anger. And we can transmute that into creating something incredible, something called an empire. As Dr. Walker said, my name is Dr. Olga. And yes, I am a cannabinologist and proud to be one. I am also a budding earth shaman and a lifestyle medicine physician. So let's get started. Let's see, how can I go ahead and do this? Let's do it like this. So before we get started, I'm gonna put up my card just so you guys can know how to contact me. This will be available later on. And I'm gonna go right into it. You might be asking me, what is Tuskegee syndrome? And a lot of people have been asking me that over the last few days. Tuskegee syndrome is a concept, and it was born in between myself and my mentor, my shiro, Dr. Samara Bowen, my medical director in El Paso, Texas. One day she and I were talking about the coronavirus vaccine, if we were going to get it, and how we were going to know whether or not it was good enough for us in our communities. And we stumbled upon something we couldn't put our finger on. It was a reluctance. How were we going to get our people to participate in clinical trials so that the medicine matched our genetics? And so we conceived this concept. And what I noticed was an orb of brainstorming energy was being passed like a volleyball between she and I. And it grew and grew and grew until we realized that something was wrong. We didn't even want to get involved. And that became Tuskegee syndrome. And from there, I took on the concept to develop this talk while she took on the concept to develop the rest of these webinars. And we became fervently settled that we were going to help transmute our past to get people involved in our community so that the medicine matched our destiny. So before we get started, I want you guys to really root yourselves in what I'm going to talk about. And I want you to feel what I'm talking about. I don't want you to run from the history. I don't want you to run from the pictures, from the tingling behind your salivary glands, from the butterflies in your stomach as you listen to what I'm going to tell you about our history. But I want you to hold it because we're going to use it later. Tuskegee, the history. The Tuskegee experiment was formerly called the U.S. Public Health Service Study of Untreated Syphilis in the Negro Male. And it began in 1932. It was only meant to last for 6 months. It involved 600 African-American men, mostly sharecroppers, in Macon County, Alabama. It also involved doctors, from the US Public Health Service, and it's important to know that the title was doctors. These researchers convinced local physicians that after these men were infected with the syphilis disease, that they should not treat the participants for any symptom, but instead send them back to them. And they would watch these men deteriorate, and they would watch the natural progression of the disease without offering treatment. Even when penicillin became the drug of choice in 1947, 15 years later, and became known as a curative option, they still withheld treatment. It was not until the mid-1960s that a man named Peter Bruxton, a physician that came on to help, whistle blew, and he asked the committee to pay attention and to stop the studies because it was inhumane. They listened to him briefly, but they did not stop the studies, and instead they decided to continue until the men died. They would conduct autopsies and continue to watch as the disease ravaged them, knowing that they could have saved them. Finally, the program ended in 1972 after Mr. Bruxton called a reporter friend. By then, 28 people had died from syphilis, 100 died from complications, 40 of their spouses contracted the disease, and 19 children were born with syphilis. After this atrocity was committed, an apology was given, a $10 million award was given in 1973, and the survivors were given health care. Tuskegee's ancestry, that's who preceded Tuskegee and who came after Tuskegee. You guys may recognize this gentleman. If you don't, I will tell you his name. J. Marion Sims, known as the father of gynecology. Sims performed unspeakably painful surgeries without anesthesia on Black slaves, believing that the operations were not painful enough to justify the trouble of relieving them of their pain. Now, I don't know if anyone has ever experienced the pain of a tearing uterus, a tearing vagina, but it is not fun. This was in 1857, and he taught other people to agree with this, to believe in this, and to go on to be physicians as well. He passed on that mentality like a generational curse onto other students. They called him the father of modern gynecology, but I ask you, was he more the father of modern cruelty? Next, the Guatemala syphilis experiments. 1946, 5,500 participants, 1,300 purposely infected with chancroid, syphilis, gonorrhea, and other STDs. Only 700 would be offered some treatment. The others offered nothing, except for an apology. And the famous doctor trials from Nuremberg, Germany. Now, I really want you to pay attention to this. This is a picture of Karl Brandt, who was sentenced to death in 1947 for atrocities he committed against Jews and others during the Holocaust. Of note, US judges left US soil to go to Germany in order to try these physicians. The trial only lasted 140 days in order to convict 6 of those physicians and condemn them to death, and they would be executed within the year. Swift justice. So now that you have that with you, keep it. I'm going to help you release it in a second. What did we learn from Tuskegee and others? We learned something incredible, a massive lesson: how to ethically conduct clinical trials in the United States and how to hold those true as standards over and over and over again. So that means if you want to conduct clinical trials in the United States, you must meet all of these 7 principles. Social and clinical value, which asks the question, is the study even worth conducting? Scientific validity, which asks the questions, can the question being asked actually be answered? Are the methods being used valid enough to answer those questions? And is the point clear? Fair subject selection states, who are the relevant participants, meaning are only the relevant participants being used and are irrelevant participants being excluded? For example, if you want to study children, you don't include 85-year-old participants. Favorable risk-benefit ratio, which asks the question, has all been done to minimize risk and maximize benefit? Independent review, which asks the question, has an unbiased review board been assessed, assigned, and have they assessed the research? Informed consent asks the question, have the participants been fully informed in a way they understand, and has informed consent been provided? And finally, respect for potential and enrolled subjects asks the question, have all candidates been treated with respect, whether they are participating or not? So now you know the principles that we have. Now we're going to put it to the test. So now we're going to start releasing that energy. Remember, we started with pain or numbness or anger. Now we're going to use the fruit that we got from that, those atrocities, and use them for present day analysis. So we're going to start with the Moderna and Pfizer clinical trials. This next slide, I'm going to go as slow as I can, but I want you to gather information. Moderna, phase 3, ongoing, but we do have some data. These are the links that Shelley, if we could put them in the chat so that you guys can follow along. And it's really just so you can get a good look at what it looks like when you're looking at clinical trial data. I don't want it to be just me. I want you to know what it looks like. I want you to get comfortable with it. 30,000 plus participants received 2 doses at week 0 and week 4. They received either Moderna, vaccine, or placebo, and then they measured the results about 24 weeks later. The vaccine efficacy was measured by using an assay that measures IgG and a nasal swab. No pregnant women or breastfeeding women were included. They did use an internal review committee. They appointed the committee to watch for outcomes and who should drop out. They provided and verified all participants could provide consent once informed. And so far, they included these parameters: most of all ages, ages over 65, about 50% male and female, Hispanic and Latino, white, African American, that's our percentage, Asian, American Indian, Native Hawaiian, and other, and multiracial. Pfizer, by comparison, phase 2-3, here are the links that we will put in the chat. 43,000 participants in phase 2-3. Half received placebo, half received the vaccine at days 0 and 21. They measured the results after 7 days of the second dose. The purpose was to measure the efficacy. No women that were pregnant or breastfeeding included, and the same review boards and standards for review boards were included. They did provide informed consent, and this was the demographic breakdown. 9.8% African American. Of note, they also studied outside of the country. So that included countries of Argentina, Brazil, South Africa, Germany, and Turkey. So now we are going to practice bioethical analysis. This is where you guys are going to get involved. I want everybody to know how to do this because technically these trials are going on. That means if you elect to receive the vaccine, you need to be able to analyze whether or not they ethically conducted the trial. This is your right. Moderna, social and clinical value. Now we remember that asks the question, is the study worth conducting? So briefly, if everyone can put in the chat, yes or no, do you think that this trial was worth conducting in order to find out the efficacy of the Moderna vaccine? I said yes. Scientific validity. Ask the question, can the question be answered? Meaning, were the methods valid? Was the question answerable? And were the points clear to answer the question, yes or no? This is just for Moderna. I put yes. Fair subject selection. Now, slow down, slow down. Let's think about this. Fair subject selection asks the question, were all relevant participants included and were irrelevant participants excluded? Think about all the relevant participants. My answer, and we'll talk about later why. Favorable risk-benefit ratio. It asks the question, remember, it has all been done to minimize risk and maximize benefit. Now, you had to have read through this, but I read through it for you. And I will say, for a clinical trial, the answer was yes, in my opinion. Independent review, which means that they assign a review board that was unbiased to assess the research. Yes or no? Yes. Informed consent, meaning was it provided and in a way that the people that participated could understand? What I found was the answer to that question is yes. And finally, was respect for potential and enrolled subjects provided at all times? Now, this gets a little tricky. I put a question mark. And the reason why is because this is ongoing. How are we going to verify that all the participants, both that participated and decided not to, were treated with respect? This is something that we would all stop on and say, let us call, there's a number, and let us find out if we can speak to the participants or if there's a survey what the participants would have filled out. And we can determine if they were treated with respect. So that's why I put a question mark. Now we're going to do the next one for Pfizer. Social and clinical value. I'm sorry, I went ahead of it. Yes or no? I put yes. Scientific validity. Did they use methods that would be able to validate and answer the questions that were being posed? Yes. Fair subject selection. Did they involve all relevant subjects? I put no. Favorable risk-benefit ratio. Yes. Independent review board assigned? Yes. Informed consent provided? Yes. Respect for potential and enrolled subjects. I was not able to find any information in the clinical trial paperwork that I let you guys have the link for, so I left it as a question mark. That means I would be calling the company to find out if I can find out more information. Okay, so let's talk about fair subject selection. Pregnant and breastfeeding women were not included in either of the clinical trials. Now, this might have been necessary because of stigma, because of not enough research previously done on pregnant women for other conditions. And it usually is the way, but in this case, I would say that's not acceptable because both pregnant Black and Hispanic women are 5 times more likely to be exposed to coronavirus. And pregnant women in general, according to the CDC, when infected by SARS-CoV-2, which causes COVID, are 5 times more likely to have a severe outcome and be hospitalized versus non-pregnant women. That tells me that our pregnant women should be included so that we can determine if they should get the vaccine. But they were both excluded. And this is why I gave an X for the fair subject selection portion of the bioethical analysis. Let's move on. Vaccine development and biomedical innovation. Why our participation in research is vitally, vitally important. It's for our community. So diversity in clinical trials benefits everyone. And they predict by the year 2040, roughly, the minority groups will become the majority. What that means is that we will make up the population of people that require healthcare. That means that we need to be doing research now on ourselves now, not waiting. Today, African Americans, Hispanics, and Asians make up the minority of group participation at disproportionately low percentages. And we know that genomic data is gathered from clinical trials, and it really is almost impossible to gather any other way. So if we want innovation in time for when we become the majority, we need to participate now. So this is for our community. It is also for you. You gain access to cutting edge treatments. You receive care from top physicians. You become a vital part of finding new treatments, and more importantly, you empower yourself. Now, I'm not advocating that you yourself participate, but I am advocating that you at least think about it, that you at least do the part to create that brainstorm or between yourselves, to talk about it with your physicians, with your colleagues, whether you have a medical background or not, and to talk about it inside of communities where lobbyists and networks are hearing you and helping you dispel the fear, change the myth, and involve ourselves. And finally, I want us to pay very close attention to this slide. Viral vector vaccines offer something called gene therapy. Watch how this goes. The gene is put inside a weak virus that is strong enough to dock and inject genetic material inside of a cell, but not strong enough to cause any other virulence. That genetic material can either be in the form of mRNA and be transcribed inside of the white part of the cytoplasm, or it can be genetically engineered to inject into the nucleus where the DNA lives. What does that mean? That means that faulty genes that are in our children can be replaced with genes that are not faulty. Faulty genes that are in our mothers or fathers that cause diabetes can be replaced with genes that don't. This kind of technology, biotechnology, the research we should be involved in because it matters to us. And after all, we are the future majority. So in other words, participation is for them. This slide is to show us the present day viral vectors that we have the opportunity to participate in clinical trials, either verbally as brainstorming or as our own bodies or as our money and funding. AstraZeneca and Johnson & Johnson are trying to create a viral vector vaccine. Inovio, a DNA vaccine, and we know about Moderna and Pfizer's mRNA vaccines. These cutting-edge biotechnologically sound pieces of innovation are essential for us to participate in. So I ask the question, can we really make a better future for ourselves? Absolutely we can. And I go a step further. We just did. We, without you even realizing it, transmuted the terror, the anger, the sadness, the numbness, the quiet, the triggers into us doing something, into movement. We just started the dialogue. We just birthed it in ourselves, just like Dr. Bowen birthed it inside of me. We are in the process of changing our future, using what they used before, which was just our bodies and minds, taking it back and turning it into something that will become our empire. We start with COVID. We continue with our money, our voices, ourselves, our community, our children, and our faith. I want you to consider joining a clinical trial or talking about one. You do not have to know anything. You just have to do something. This is a link if you are interested. I am not advocating for you to join a clinical trial. I'm advocating for you to transmute your past and innovate your future. I want to thank you all today for having me. You have no idea how swollen my heart is to be able to talk about this, to be a part of our history, to be a part of our solution, to be a part of our future, to be a part like Dr. Kizzy. Thank you so much. Namaste. Ashe. Dr. Walker, I'm done.
I am smiling so brightly because one of the things that we talked about for this session is we wanted you, every single one of you who showed up, to feel empowered, to say that there's nothing magical about this work and this knowledge and information. We just have to talk about it, and we have to talk about it to each other. And that is what we're about to do. Now, in order to do that, in addition to Dr. Obi, I have the extraordinary pleasure of introducing two other phenomenal Black women. And I want you to notice, this is all Black women supporting and uplifting each other and recognizing greatness, and thanking all of you for being here today and participating in this conversation, because that's what this is. This is a conversation among us. As I mentioned in the chat, this is for us, by us. Now, our other two panelists. I'm going to start with introducing Dr. Cinta Georgia. She is smart, y'all. She is so smart. She is an assistant professor of pediatrics and stem cell biology and regenerative medicine at University of Southern California Keck School of Medicine. She attended Stanford University and received her BS in biological sciences, then got dual departmental honors in biological science and ethics in society. So she was initiated into the Alpha Kappa Alpha sorority as a member of the Xi Beta chapter in 1998. Now, I told you she was smart. She went on and earned her PhD at UCLA in molecular biology, and her dissertation focused on the role of cell cycle molecules in the establishment, expansion, and maintenance of beta cell mass. Now, once you get your PhD, you're still not done. So then she became a postdoctoral fellow and assistant adjunct professor at Hillbaum Islet Research Center at UCLA. And then she looked at like DNA methylation and how it affected like your pancreas and pancreatic organogenesis. And even like looking at beta cell identity. And for those of you not in medicine, when you hear words like pancreas and beta cell, you should start thinking about diseases like diabetes. And I'm sure most of us know somebody who has a touch of the sugar. Now, beyond that, she has her own lab, like where she shows up every day and does science and research at Children's Hospital Los Angeles, using both animal models and human stem cells to study molecular mechanism that governs differentiation, function, and regeneration of beta cells in the context of development disease. But of course, as an Alpha Kappa Alpha woman, she remains active in the Theta Mu Omega chapter, and she's held offices of Grammatis, Parliamentarian, Antibacillus, and Bacillus. Now, she's a member of the Beverly Hills West chapter of the Lynx Incorporated, a native of South Jersey, a wife, and a mom to 4 active young children. And in case you wondered, is she human? And is she someone you could just talk to and hang out with? Absolutely. She loves thriller and horror films, and she can cook you a really good meal. So that is Dr. Georgia. Now, not to be outdone in the least, I'm telling you, this was the favorite part of this for me, is talking about phenomenal Black women. Dr. Wellaway is also similar to Dr. Obi, born and reared in Texas. Specifically though, not Houston. We're gonna give some love to the Dallas-Fort Worth area. She received her MD from the University of Texas Medical Branch and graduated magna cum laude with a distinction in research. She went on to complete her internal medicine internship at the University of Oklahoma, Tulsa, and then did her residency in internal medicine at the University of Texas Medical Branch. Now, once she completed her medical training, because as you can tell, we don't stop at mediocre. We go above and beyond. She worked as a hospitalist at Sparrow Health System in Lansing, Michigan for 6 years. And while she was there, she took the world by storm. She was a clinical assistant professor at Michigan State, medical director of the hospitalist services for the system, co-leader of their new internal medicine residency program, vice chair of the Department of Internal Medicine for Sparrow Hospital, and executive medical director of clinical operations throughput. Not surprisingly, she was physician leader of the year in 2017 for their health system. But she didn't just stay there and rest on her laurels. In 2018, she moved to St. Louis and became the medical director of the BJC Medical Group Hospitalist Service at Christian Hospital. This woman is leading and creating change and making an impact everywhere she goes. She led multiple initiatives to practice efficiency and excellence in care, making sure that if you showed up at her hospital, you were going to get excellent medical care. And just last year, Dr. Wellaway led the COVID-19 response for her hospital. And if you don't know, Missouri is one of those states that was hit particularly hard with people suffering from COVID-19. As I've alluded to, she has a national reputation for her work in hospital medicine and in medical ethics, which is really important. It's the why of what we do and why we do it and how we should do it. Now, right now, she's a medical director of hospital medicine at Baylor Scott and White in Fort Worth, an assistant professor at Texas Christian University and University of Texas Health Science Center School of Medicine. She's also a core faculty member of the new Baylor Scott and White All Saints Medical Center and the TCU UTHSC Internal Medicine Residency Program. Y'all, we are about to have a phenomenal conversation with Dr. Oga, Dr. Wellaway, and Dr. Georgia. So hopefully I can get all of them on the screen. I think I just need Dr. Obi to come back. All right, ladies, I'm gonna switch things up just a little bit because people were so excited to be here. They sent in so many questions, and I know we could talk to each other all day, but we gotta make sure we answer the questions that people have. And so bear with me because I gotta switch to a screen that like goes on forever with these questions. But I'm gonna start with some of the questions that people sent in for us. And one question I wanna start with, and I'll let you choose who should answer it. First question for our panel. Why is COVID-19 such a big deal? We know that people die from the flu every year. What's the difference between COVID and just getting the flu?
I guess I can start by taking that. I would just like to thank you for the wonderful introduction. I would just like to, before I answer that question, go back and clarify one thing, that when we set up research projects, whether they are preclinical research like the work that I do or clinical research, we always have to make sure that we test things in populations that are most resilient first and protect populations that need to be protected. So pregnant women, breastfeeding women, children, people with mental disabilities are all protected classes and do not generally come in the first wave of a clinical trial, especially for things that have never been tested before. And so the exclusion of pregnant women from the first wave of these phase 3 clinical trials for all of these mRNA vaccines that have come out was actually a precaution and a protection for pregnant women. And we understand that pregnant women are susceptible to COVID-19 and that they are really anxious to get the vaccine. But pregnant women are also naturally immunosuppressed and they're carrying an unborn child, and that unborn child has a developing immune system. And so to expose an immunosuppressed person and a developing infant to an unknown vaccine where we cannot predict how that will interact with their immune system was deemed unsafe for the first phase of clinical trials. And so I just wanted to be very clear about that. The pregnant women are a protected class when we talk about the checklist and the ethical considerations that go into developing clinical trials, and that's why they were not part of that. The other thing, before I answer this question, I also just need to make sure that everybody understands is that we can use viruses to deliver genes to certain cell types, but we cannot replace genes that cause diabetes. I work on that one specifically, or just about anything else as a form of gene therapy at this time in practicing medical science. There are a few gene therapies that exist, one of which we do deliver at Children's Hospital that affects and is effective for a small number of children that have a defect in a gene that causes blindness. But that is one of the very, very few approved genetic therapies that are on the market. We know a lot about our genes, we know a lot about our DNA, but we actually don't know what genes cause diabetes. We don't know what genes cause heart disease. And it's really important to make sure that people don't get it confused that the same technology that we're using to deliver this vaccine cannot be a Trojan horse for delivering other types of gene therapy. That's not what this is about. So I know that people can sometimes get those issues confused. And so I just want to clear that up in the beginning and we can talk about that more. Now, to answer the question that I actually just said I would answer first, why is this any different than the flu? And so the flu on a bad year kills 50,000 people in the United States. And as you know, we are on the verge of, in the first year of COVID-19, killing 500,000 people. And so even if the actual illness isn't worse than a really bad flu, the fact that 10 times more people get it is why it is a public health emergency. I live in the city of Los Angeles, where our emergency rooms were genuinely full because people needed that much help with their COVID-19 diagnosis. We were at over 100% capacity in our ICUs, meaning they couldn't take anybody else. So if you were sick and just had a heart attack, you might not get a bed because there were just no beds left. Some ICUs were completely full of people who had COVID-19. Did you just get in a car accident and your arm is broken? You are way down on the list of people who can be treated. So even if for most people it ends up being just like a flu, for 10 times more people than get the flu, it's actually really, really bad and potentially deadly. And so we can't let that get out of control within all of our society. And so that's why it's a public health emergency to try to get COVID-19 infections under control, to preserve people's lives and to preserve the stability of our healthcare system, to be able to take care of as many people who need it.
Thank you so much, Dr. Jordan. I appreciate the answer. Dr. Wellaway, did you want to jump in and just add to that?
I was going to add, some people ask me sometimes, is this the most infectious disease we've ever seen? And the answer surprisingly is no. But the difference here, as Dr. Georgia mentioned, is the people are very sick, but not everyone is sick. So in the past, extremely deadly diseases, people appeared ill, and people knew this person is sick and I need to stay away from them. COVID-19 has not been like that. There are people who have zero symptoms. There are people who feel like they have allergies. There are people who are very, very sick that we're taking care of in the hospitals. And so I think the big difference with this disease particularly is that you don't always know who's who, which makes it easier to spread.
And then I wanted to stay with you and ask if you could tell us a little bit, because this is one of the questions that came in, Dr. Wellaway. What are the contraindications to getting the vaccine? Like, who are the people who maybe shouldn't get it? It's not safe for them. And if there's someone who's not on mute, will you mute, please? Go ahead.
So that's a good question. At this point, there are not a lot of people that should not get the vaccine. People ask me about allergies. You know, I have seasonal allergies. Should I get it? Yes, you can. People who have had anaphylactic reactions. So that is, I came into contact with a specific type of drug, and from that, I couldn't breathe. I had a really bad rash. I had to go to the hospital. People in this situation often carry EpiPens because they know that they can have these type of reactions. And even for those folks, the recommendation is that they speak with their physician, their allergist, get the vaccine, but take your EpiPen with you. Another class has been, you know, I had COVID and I'm recovered. Should I get the vaccine? And the answer to that is you can. The recommendation has been to be about 90 days out from your initial infection, because some people who have had the vaccine that have taken it a little closer in proximity to their disease have had some reactions. And those reactions, I think we might talk about too a little bit later, but feeling fatigued, definitely fevers, chills. I know some people in the chat talked about some of those symptoms as well. Usually self-limiting within 12 to 36 hours if it's clearly due to the vaccine.
Thank you so much. I wanted to direct a question to Dr. Ogo. One of the other things that came in from the audience in advance, I'm telling you, people showed up ready for today. Are there any chemicals in these vaccines? And we know right now there are 2 that are approved, and more than likely at least 2 more that are coming. But from what you know, are there any chemicals in the vaccines that might adversely affect Black and brown people?
Well, I guess that depends on the individual. Black and brown people are not genetically monolithic either. And so it would depend on whether or not you have had previous reactions to other vaccines, because vaccines come with preservatives and they come with carrier solutions. So certainly if you have reactions previously, or you don't know if you have an underlying allergy predisposition, for sure. But I would not be able to say if there are chemicals that affect across the board. Dr. Georgia may be able to enlighten us a little bit more about the ingredients that are in vaccines, but to answer your question, whoever that was for, it would probably be based off of your predisposition for allergies and then what the chemical is. But there are chemicals that come with vaccines.
And I think you brought up a good point, because a lot of times we say, and a lot of people think this, and I want to just pause for a moment and really emphasize this. Race is not real. Race is not biological. Race is something that was made up to perpetuate racism. Now, we all do share ancestry. We absolutely share culture. But the idea that you being a Black person determines your genes or how your genes operate, that is a false notion. So absolutely, you need to think of yourself as an individual and think about your family and your own family history. And as mentioned, I know someone who does have a reaction to preservatives. Like, she has a life-threatening reaction to like certain chemicals and dyes. Those are things that more than likely you probably have already figured out in life. There's not going to be something new in the vaccine. And so that's important, not to let anyone, doctors, scientists, other people, just lump you into a category and say that you are a certain way just because you're Black or things like that. So I hope everyone has heard that before and understands why that's really important. So Dr. Wellaway, you talked a little bit about vaccines and allergies. There were a few more questions that came in about this, and I'm going to direct this to any of you that want to answer. But along those lines, if you have had an allergic reaction to the vaccine, like say you got your first dose, should you get your second one?
Can you hear me now? If you've had a severe reaction to the first dose requiring hospitalization, it is most recommended that you probably hold off on getting a second one if clearly that reaction was due to the vaccination. Now, that being said, if you had redness of the arm, fatigue, fevers, chills that lasted, again, 12 to 36 hours and resolved on their own, that is not a contraindication. So you can go ahead and get the second dose. And just to clarify a question I saw on the chat too. So 90 days definitely for anyone who's received a monoclonal antibody. So that's one of the treatments that we're giving people who have COVID, as well as convalescent plasma. Another treatment that we're giving people who need to be in the hospital, you have to be 90 days outside of that treatment to get the vaccine. But for people who have had COVID and are feeling okay, they don't have to wait a full 90 days. That is true.
So another thing that maybe we can clarify, people, is what's the difference between having symptoms because your body is reacting the way it's supposed to in terms of building up the antibodies you need to fight off infection versus having a bad reaction to a vaccine where something you're like, whoa, this was not good for me. So what's the difference between the two? And maybe I can take that question back to Dr. Georgia to answer first, and then either of our other panelists can jump in.
I'd actually leave that to your other panelists because, again, I'm not a physician, and so I don't really want to talk about the difference in the responses in terms of the way that people feel and how they can parse out those differences. Not my lane.
Maybe if I should have clarified. Yes, I thought maybe if you wanted to speak more to like the immune kind of response reaction, like making antibodies versus like getting a reaction, if you feel comfortable with that question.
No.
Okay, no problem. Thank you for clarifying. So I'll pitch it back to my other two physicians.
So I can speak to some of the differences that you might see, and what we're telling people who come in to get a vaccine is you can experience some symptoms that look similar to being diagnosed with COVID. So like I said, fevers, chills, fatigue, swelling or pain at the site of the injection, some redness there. Outside of obviously the injection site, you can have those symptoms with COVID as well. Some things that you will not get from the vaccine is a loss of taste or smell. And I think a lot of people have heard that's kind of a tall tale. Yes, that's something that we really don't see regularly with any other disease processes. And so loss of taste or smell, even after you've been vaccinated, that's someone who needs to be tested for COVID.
And then this question came up fairly frequently. If I've had COVID, why should I get the vaccine? Why do I need the vaccine?
I am happy to answer that question. So the idea behind a vaccine is that it will allow you to have a by proxy immune response. If you have had an actual immune response and you are for sure certain that you have titers, which means that you can measure that your immune response still exists, then you do not necessarily need to have the vaccine. But if you cannot verify that after having had the disease that you have titers, then it would be recommended that you either measure yourself for titers, which is, I think, possible, or consider getting the vaccine. And this is just based off of my theory, thinking about how the immune system works and how you would want it to work in order to prevent getting a severe disease. I also want to talk to people about what it means when you develop a disease. So developing a disease is a development of symptoms. It has nothing to do with whether or not you are infected with the virus. Infected with the virus means that something came to your door and it's inside of your house. Does not mean that you're shooting it up and killing it. So if a virus invades your body, you may not develop the disease, the dis-ease. That is the immune response that is mounted as a result. But it does not mean that your body is not mounting an immune response. So I get the question a lot, and oftentimes I get it sarcastic, so I relate to whoever asked that question. If I've already had the disease, do I need to get a vaccine? Well, we need to make sure that you've had a proper immune response, meaning that later on, if the virus were to come to your door and it got in, would you have severe dis-ease symptoms? And I think the idea is that the vaccine would help you to have a proper immune response that is measurable, that would prevent you from having severe dis-ease. I hope that makes sense.
Yeah, and I think the other thing I would add to that is some of people may have heard that when you have COVID-19, some people have no symptoms at all. Some people have mild symptoms. We worry about, as Dr. Georgia said, the 500,000 people, mostly Black and brown people, our Native American indigenous people, ending up getting sick and dying. But even if you don't die, there's something that we're recognizing as a post-COVID syndrome. And these are symptoms that linger: brain fog, confusion, fatigue, Some people don't get their taste of sense or their taste or sense of smell back. They're still without it months later. We've seen increased strokes and heart attacks even, and all of these complications because of infection with the virus and the way the virus invades your house. So the idea is getting the vaccine that you've got your guards on duty 24/7. If that vaccine shows up, it's like, not today. And the idea is not just protecting you from something that's like the flu, but also protecting you from this post-COVID syndrome that we're still researching, that we're still studying. The other thing I want everyone to know is that we're not here to tell you that we have all the answers. As you can see from the data that we've presented, we're figuring it out as we go. And as doctors, sometimes it's hard for us to say that because we're supposed to be smart, we're supposed to know it all, the answers. But this virus hit all of us by surprise. And we've learned a lot in the past year, but we still have a lot more to learn. And what we know, part of why we're here today is to make sure that you know and that we get your questions answered. Now, with that, I'm going to go through a few more audience questions. Then I'm going to flip to a couple of questions for our panelists that we specifically thought it would be a good discussion for you to hear. Because I think the other thing, I was just going to say, the other thing that people don't know is that we don't always agree as physicians. And part of what makes us smarter and makes us better is when we debate and when we question each other and when we push each other like, no, prove it to me. Where are your facts? What is your data? And I want for people to hear that exchange and understand it doesn't make any one of these women less brilliant, but that's a part of how we all get better, is asking those hard questions. So Dr. Georgia, you were going to jump in before I ask the next question.
I was. So I just wanted to say that the studies that the emergency use authorization approved, or the studies that were presented for approval for emergency use authorizations of these vaccines were actually relatively short. And so when we say that the Moderna or the Pfizer vaccine is 95% effective, we know that it's 95% effective within the first 2 to 4 weeks after somebody got it. And the thing that's really interesting about coronaviruses and how our bodies mount responses against it is that it is one of the few viruses that we don't tend to be able to mount a long-term response against. And so there are people, aside from being vaccinated, who get the coronavirus and actually get it a second time because their body did not maintain that antibody titer, the capacity for their immune system to respond and fight off the virus a second time. So just because you've had COVID-19 does not mean that you have that antibody titer. And we've seen that in multiple patients. There are studies that say within 8 weeks after having COVID-19, your antibody titer can be gone. There are other more recent studies that say that they can see antibody titers stay high for as much as 6 months past having COVID-19. So this is a place where the data is still not very clear. So just because you've had COVID-19 does not mean that you are fully protected from getting it again. So you should get vaccinated if you choose to, and especially if you are exposed to high-risk environments. And just because you've been vaccinated with the COVID-19 vaccine, we are not sure how long that protection is going to last. You might need to get vaccinated every year, just like you have to get vaccinated for the flu shot every year. That's one of the things that we are learning as we go along doing this work.
And Dr. Georgia, that's for when you're talking about getting it the natural way, that's the same strain. I want to make sure that you're referring to. That can be for the same strain, correct?
Mm-hmm. The spike, even between these strains thus far, the spike protein, which is what your body is developing the antibody against, the spike protein has not changed enough for your body to evade the first set of antibodies that it detected within the different strains that are out there right now.
So I was just going to jump in and say thank you so much for providing that information, because that was also one of the questions. And then just explain to one how prepared I was. Because technology always fails us, I had 2 different monitors set up in case something happened. So I'm now switching to option B, and let's see if this one works for a while. So, and kind of moving on and kind of moving our discussion, you know, can you talk a little bit more about what are some of the differences that we know between, say, Moderna and Pfizer in terms of mRNA technology versus AstraZeneca and Johnson and Johnson? Now, before you answer that question, though, there's one other definition I hope you can provide to our audience. We've heard this term emergency use authorization. Can you first, before we talk about the differences in the vaccine, can you explain what that term means and then how it's relevant to these different vaccines that are approved right now?
So an emergency use authorization means that we have a problem that needs to urgently be addressed. And we are not entirely, we've evaluated the safety profile and we feel like this drug is safe enough where the benefits outweigh the risk. That does not mean that there's no risk, but the benefit of having people vaccinated outweighs the risk of what can happen to you from being vaccinated, okay? And so, for instance, we do know that people get these anaphylactic reactions, relatively rare for someone to get an anaphylactic reaction. But the risk of you getting an anaphylactic reaction is less than the risk of you dying from COVID-19. That is what an emergency use authorization says. It's not giving the full stamp of approval to say that we understand everything that this is and that you will be, these are the risks and these are the benefits. This is saying that we have an emergency on our hands and this is what we know. And from what we know, does the risk of you taking this, does the benefit of you taking this outweigh the potential risks that come along with that? And so that is what has propelled these vaccines forward thus far. It is safe as far as we can tell you. And because for the things that we have observed of happening to people who get the vaccine are much more rare than the actual possibility of you dying of COVID-19. That is what emergency use authorization, those are the facts that they weigh. And we've weighed those facts for adults from the age of 18 to 88. We actually haven't made those same assessments for children yet. Seems like it's okay for kids as young as 16, because I think that the Pfizer vaccine had a few 16-year-olds in their trials, and now we're extending that down to 12-year-olds. But we're still not sure yet, and that's why children are not part of a part of this emergency use authorization. Not sure that the risks outweigh the benefits for pregnant women. That's why they're not part of that emergency use authorization. And that's why it still takes additional studies to evaluate the efficacy and the benefit of people getting vaccinated in these protected categories like children, infants, teenagers, pregnant women, breastfeeding women. We need to evaluate all of that in the context of what we know, and what we know is still growing.
So I want to put some historical context, because I think Dr. Oga did a great job of telling us we have to kind of know our past to understand our future. When it comes to vaccines, some of you may or may not remember the polio vaccine. And at the time, there was an urgency to create a vaccine because there were children and adults dying and suffering from polio. Some of you may have heard of this term like the iron lung in terms of treatment. One of the things that's very relevant for me is I have an uncle who developed polio as a child, and he also developed a post-polio syndrome that he still has disability that affects him to this day. Now, he's amazing, fully functional, keeps all of us in line, phenomenal cook, chef. So he has a full life, but it was the idea of we could have prevented him from getting this infection. Some of these post viral syndrome issues that he suffered from the rest of his life wouldn't be an issue. So that idea of we do this emergency use authorization because 500,000 people have died. So there is absolutely a tragedy unfolding. And some of you have touched on this in your comments in the chat about the impact of racism. And that's also why I really loved what Dr. Oga was saying about we have to do more to take care of us at the scientific level, at the medical level, and as a community. So I'm going to use that as a segue into that second part of the question I asked, not just emergency use authorization, but what do we know about some of the differences between these vaccines? 2 shots versus 1 shot, effectiveness. Dr. Georgia touched on this a little bit, but I didn't know if Dr. Oga or Dr. Wellaway wanted to add a little bit more information.
Dr. Wellaway?
No, I think we're going to learn more as more of these vaccines get the EUA and more people get them. I'm not an expert in mRNA vaccination, so I can't speak to that. I did see a question in the chat about, how are some of them 1 vaccine versus 2? And it goes back to what Dr. Georgia talked about and Dr. Obi talked about. And we're trying to maintain that response so that if the body sees the virus again, we're ready to fight. We identify it and we don't get the disease or get sick from it. And so that's what it's all about, is however long we can maintain that amount of antibody so that we can fight the disease. And we'll see, the Johnson & Johnson vaccine looks like they're getting pretty close, and that's a one shot and won't require the very low temperatures that these current vaccines require. So hopefully that will make it a lot easier to get to everyone too, which has been one of the issues.
Yeah, and so I would say so far we have Pfizer and Moderna. These are 2-shot vaccines. They do use this mRNA technology. The wonderful thing about science is we do have someone like Dr. Kizzy, and we have people like Dr. Georgia that are working on this and bringing science into real time. So just like not too many of us are still holding on to our flip phones from, over 10 years ago, most of us are trying to get with the latest iPhone or Droid. The same thing happens in science. So the vaccine technology that maybe has been around for 50 or 60 years, it still works. But you probably or possibly may get more bang from your buck from that iPhone 10 than from your Razr 1998. And that's, a fun way of talking about the vaccines, but it's relevant. So with Pfizer and Moderna, think of them as your, Samsung 10 and your iPhone 12, and it works, and it works really well, but it is new and there is a learning curve. We have a lot of data. Pfizer is a 3-week, Moderna is 4 weeks between the 2 injections. They were 95% effective. There was about 10% of Black people that were enrolled in these studies. Several physician colleagues that I have personally enrolled in these studies, and these are my Black physician colleagues of all ages. So one of my Black mentors from my fellowship program, he's like in his early 60s, and he was an enrollee, as well as one of my other mentors who's in her early 50s. So wide range. As was mentioned with the Johnson & Johnson and the AstraZeneca, these are looking like they'll more likely be 1 dose, and they are kind of relying on some of the older technology. Now, if you're someone who doesn't like a lot of shots, or you just can't get that many days off work, let's be realistic. If by the time you're eligible for the vaccine, get what you can get. And if it's Johnson & Johnson, we're learning more that even though that one dose may initially just be 65% effective, we're continuing to study the research subjects, the people who are in those trials, and it looks like the efficacy gets a little better the farther out they go. It seems like your body remembers, like, oh, I've seen this before. We not doing this again. So that's promising, and but that's also good, right? Someone talked about how much does pharmaceutical companies make off of this. In a way, you want competition. You want people competing to make something that's better. You want to make sure we have enough for everyone. And in recognizing, let's say you have an allergic reaction to this, so maybe this other vaccine may be safer for you. So I'm going to ask one more audience question, and then I'll flip it back to some questions. Maybe we'll get into some of the ethics of this work as well. What
Before
about
you go to the audience questions, can I just chime in?
Sure, absolutely.
So the difference between Pfizer and Moderna versus AstraZeneca and Johnson & Johnson is that as you know, that it's an mRNA vaccine that is what Pfizer and Moderna is. So what does that actually mean? Okay, mRNA is something that your cells make all the time. If you think about, like, you have DNA, and your DNA has to tell your cells what to do, and the way that your cells does do things is by making proteins. Well, RNA is that middle step between DNA and protein. So your DNA tells your cells what to do using RNA as an intermediary. So RNA is something that we all have inside of us all the time. And what Moderna and Pfizer have done is that they have synthesized a very small piece of RNA and then encapsulated it in what they call lipid nanoparticles. And so when you were asking about the chemicals and what are the type of things that may or may not be harmful for you in these new vaccines, lipid nanoparticles are relatively new technology. And it's the lipid nanoparticles that protect the mRNA as it is coming out of the syringe and actually allows it to bind to your cells and get into your cells so that it can act as a direction to make the protein, that spike protein, that you need to activate your immune system, okay? So basically what Pfizer and Moderna have done is created that intermediary mRNA that your body already uses and made that intermediary make the spike protein for the coronavirus. Now, the spike protein is not what makes you sick in coronavirus. So it's not that the vaccine can make you sick, but it is the part of the coronavirus that your immune system recognizes. So the mRNA for just the spike protein is covered in these lipid nanoparticles, which are, a lipid is a fat. And those lipid nanoparticles can bind to your cells and push the RNA in. And then once the RNA gets in, it tells your cells to make the spike protein and spit it back out. And so once it spits that spike protein back out, your immune system says, hey, what is this spike protein? And builds antibodies against it. And that's how you become immunized against the coronavirus. The problem is that mRNA is inherently unstable. It doesn't like to be warm. It doesn't hold up well to warm temperatures, which is why both the Moderna and the Pfizer vaccine, Pfizer has to be kept at ultra low temperatures, less than minus 80 degrees Celsius. And the Moderna vaccine has to be kept in your regular freezer, minus 20 Celsius. Okay, then moving to Johnson & Johnson and to AstraZeneca, they don't have to be kept at low temperatures because they are a newer type of vaccine. So this is not the same type of vaccine that is made when you go and get your like MMR vaccine or whatever are the little things that you get every couple of years, or even the flu shot, which is actually made in eggs. This is another type of actual virus called an adenovirus or an adeno-associated virus, depending on which one of the two companies that you're working with. We've worked with adenoviruses in cells and in animals in the lab for years. And so they put, again, instead of using mRNA, they're actually using DNA. So DNA, just like this in your cells, but they put a small piece of DNA in the adenovirus that gives the directions for your cells to make RNA to make the spike protein. And they use a virus instead of these lipid nanoparticles to get that spike protein DNA into your cells. The benefit to that is that DNA, unlike RNA, is very stable. So you don't have to put it at ultra low temperatures to be able to distribute it around. And so that's the difference between these two things. We've never used mRNA vaccines before. To my knowledge, the only adenovirus vaccine that we have is actually the Ebola vaccine, and that's been on the market since 2018, I think. And so we do have data for using adenovirus as a carrier for vaccination based on all of the trials that they did for the Ebola virus. And those vaccines have worked really, really well in the affected areas. And so there's a little bit more data for the safety and efficacy of using adenovirus than there is for using mRNA. And I'd also just like to shout out my sister. Her name is Dr. Shalimar Georgia Clark. And she actually has been working on the coronavirus since before any of us knew what it was. She is a practicing scientist that gets dressed up every day in a spacesuit at the NIH and works for the NIAID, so the Institute for Allergy and Infectious Disease. And she has been culturing the coronavirus in the lab, sequencing it, identifying viruses and variants, testing in animals, part of vaccine development, and all of those sorts of things. And so there are lots of Black women at every level of coronavirus research trying to work on our behalf and make us all safer.
That's wonderful. Thank you. I'm so exciting to learn about your sister. And I appreciate the much more elegant explanation than I gave. So
that was my lane, so I can do that.
And that's why you're here. And we thank you so much for sharing your wisdom and your time with us. I'm serious. I'm a nerd, so I'm geeking out about being able to talk to all three of you. Let me flip a little bit. Let's get a little bit more into the ethics. So we've talked a lot about science, and there are a few questions in the chat. You all are amazing. We're trying to keep up. But ethically, why should Black people get this vaccine?
I think that's a good question, and I hear that a lot. And I'll be honest, I didn't initially sign up to be vaccinated for a lot of the reasons that we've already talked about. It's brand new. We haven't really seen this before. There's not a whole lot of data when you compare the 40,000 people to the millions of people all over the world that are at risk of getting this disease. And so my initial thought was, let's hold back. I'm going to see how everyone else does with this. You know, the more people that get the vaccine, the more information we know about it. But seeing COVID patients regularly in the hospital, seeing, again, I'm a hospitalist, so I don't see a lot of people who are asymptomatic, feeling fine, or have allergies. We see the sicker people and the sickest of the sick. And it's scary. And really, it was that same weighing risk versus benefit and the type of thing that Dr. Oga talked about. And at that point, I had decided, I think the benefit is outweighing the risk. And I decided to get the vaccine. I've had both doses. I did very well. I didn't have any side effects, which that was my decision. And when people ask, you know, are we getting it? I say yes. That being said, everyone's body is different. Everyone has different effects. So my mom got the vaccine. She's a nurse, and she felt ill and had the fever and the chills, but they went away within 12 hours. And again, it's risk versus benefit. And if we want our numbers, our 10% of the population that was studied to go up, we have to get involved. We have to be more involved, and we're more likely to die from this disease than some of our other counterparts. And so that's another thing that I think we need to take into consideration when we're making decisions about the vaccine.
And then Dr. Olga, you were going to jump in with a comment as well, I believe.
I was actually just going to mirror what Dr. Wellaway said. So I second that.
We started off because we're going to run out of time. And I'm so glad this is just part one of a 3-part series. And I want to thank you all again for being here. But we started off about talking about the study of untreated syphilis. And this was a situation where Black people were denied treatment. How do you see the comparisons today where there are less vaccines in neighborhoods with Black people, where you have wealthy white people flocking to neighborhoods they've never been to before, trying to jump the line to get their vaccine? Is that almost a repeat of Tuskegee, where we are again being withheld from the treatment that we should get?
I would like to comment on that. So when someone takes something that belongs to you or that's allocated for you, that is a codependent relationship. We have to understand that part of taking has to involve releasing, relinquishing. And there are vulnerable populations that don't feel equipped to speak up for themselves and are not defended. So the mentality did not die. We have to understand that Tuskegee ended in 1972, and it's because it was forced to end. We also have to understand that other experiments continued even after that, just not in the public eye. We also have to understand that these vaccines are in early trials, whether or not they're called phases or not. We have not reached a level or a capacity of time that would show that we are not ourselves involved in ongoing experiments receiving the vaccines. So when that happens, it is the mentality, that is Tuskegee syndrome. That is what carried it. It does not matter that those physicians were white. It does not matter that those people were physicians. It's the mentality. It's the energy involved in going to take something that is not allocated for you, whether it be from fear, whether it be from waiting to see what's going to happen and then going to take it, whatever the driving force is, that is the syndrome. And so if we understand that, and we understand the codependent nature that is involved with relinquishing or not fighting or standing up for yourself, and the other half that goes and takes, then we understand that that is the same mentality. We don't need it to be labeled. We don't need it to be studied later as an unethical thing. That is what's happening. And so I would say that part of learning from our history is learning how to effectively stand up for yourself. It's learning how to effectively influence law enforcement or other enforcing agencies. It's knowing how to contact them, when to contact them, where to contact them, what phone numbers, at websites, et cetera, that you can utilize to preempt those things or to stop them dead in their tracks. And a lot of that has to do with us talking to our direct suppliers. Those are pharmacies, those are clinics, those are our congressmen and women, using those voices to acknowledge it or to recognize it before it happens and not just during the time that it's happening.
Thank you. Go ahead.
I would like to say that I think that that similar to what Dr. Olga said, it is a matter of privilege that drives people to skip the line and get vaccines. And there's no ethical excuse to justify privilege, right? So I can't really speak to that, but I can tell you that I was hesitant to get the vaccine because I get it was new, it wasn't tested, but I had to sit down and think about what my own privilege was, how my own privilege was making me feel that way. I work from home most of the time. I go into my lab maybe once or twice a week when I have to, or when I have experiments that need to be done with my hands on them, or if students need help. My kids are at home. I turned my garage into a mini school so that they can have like a separate space to work in. And we have a bubble of other kids that come over so that they're not like isolated completely from other people. Somebody else does my grocery shopping for me via Instacart, so that I actually create a bubble for myself not to be exposed. But in creating that bubble where someone else has to go grocery shopping for me, because I'm privileged enough to pay for that, they are then putting themselves at danger for their exposure to COVID-19. And so for me, I had to look at myself and say, well, you can't tell everybody else they should go get vaccinated if they're in high-risk environments, but then you ask them to put themselves in high-risk environments. Like that did not sit well with my spirit. And so for me, it's a matter of justice. If we're going back to the ethical principles of what should drive some of our scientific decision making, it is a matter of equity and fairness and justice to me as to whether or not I should get a vaccine. I should get the vaccine because when my children go back to school, God willing that that's sooner than later for my own nerves, but when my children go back to school, if their teacher is not vaccinated, they should at least know that my family has done everything that we can, not to keep my kids safe, but now she's exposed to my kids, so that I'm keeping her as safe as I can too. That's a matter of fairness. That's a matter of justice. That's a matter of contributing to the social good. And I think that is what made me overcome my own vaccination hesitancy. Because if we're ever going to get out of this, and we are not going to disproportionately burden people who are working poor, people who are brown, then we have to, everybody has to be in on the same boat. And so for me, that was a big deal in terms of deciding to get vaccinated. And what really drove it home was me watching January 6th on television and seeing what privilege looks like. And I could not sit in a space where I knew that I was exercising a privilege that was disproportionately affecting working poor Black and brown people. So that's why I got vaccinated. I'd also like to say, right before I got vaccinated, I decided to take a COVID test just to see what my antibodies were, right? And so there are a couple of different COVID tests that are available, and some of them are available commercially. So I just want to clarify like what all of those tests are. So if you get an antigen test, that's like your nose swab, or even now they're doing saliva tests, that will tell you if you actively have a COVID infection right now. It's testing for the presence of the virus in your body fluid at that moment. If you get an antibody test, that doesn't necessarily mean that you have COVID right now. It means that you have been exposed to COVID such that your body has mounted a response and you now have those antibodies against COVID, that titer that Dr. Olga referred to earlier. We don't know how long you'll keep that titer up, but that's what an antibody test is, okay? And so if you are unsure if you actively have COVID, you should get an antigen test. If you think you may have been exposed to COVID in the past, more than 2 weeks ago, and you want to know if you have antibodies against COVID, you should get the antibody test. Now, if you have been vaccinated, you will have antibodies against COVID. So the antibody test is not going to tell you anything about your previous exposures because you will have generated that antibody from taking the vaccine. So the only thing that would provide information to you if you were to get sick would be to take the antigen test again to know if you are actively carrying the COVID virus in that moment.
And I would just add to what Dr. George has said, something that we've run into recently in our hospital is we're running COVID hubs about the antibodies. So the two vaccines that are available currently, the Pfizer and the Moderna, as Dr. George talked about as well, attack the spike protein. The antibody tests that are widely available are not looking at the spike protein. So you could get the vaccine and go to your local hospital, and the antibody test that we've been running throughout this time period may show that you don't have antibodies, and it's because we're looking at the wrong part of the virus. There are some places that do have antibody testing for the spike protein. I imagine that'll increase as more people are being vaccinated and as we start to look at titers. So just one thing to think about, if you do get the vaccine and you go and get antibody tested and you're told you don't have antibodies, that doesn't mean that you're not being protected from the vaccine.
So ladies, I need to apologize to you and to our audience. The questions are coming in faster than we can answer them, and we are over time. So the good news is this is just part one of 3 conversations we're going to have over the next few weeks. So I hope that those of you who are here today will come back next Saturday. We'll tell more people to join. Please, continue to send in your questions. I think next week's panel, we can really focus on the myths and the truths about the vaccine, some of the things you've heard. You are not gonna, one of my friends asked me, did you grow, I'm afraid I'm gonna grow an arm out of my leg. And I'm like, I've been vaccinated. I still look the same way I think I did before. Maybe a few bags under my eyes from working too much. So we invite you to come back next Saturday. We're going to continue to compile your questions, especially the ones that we did not get to today. I want to thank you for being very engaged, for asking excellent questions, and helping other people understand all of this. Again, this was just the beginning, and we promise to come back to you for 2 more weekend Saturdays to talk about this more. Of course, I have to thank these phenomenal Black women, scientists and doctors for being amazing. I want to give a special shout out to Dr. Bowen for, again, getting so many of us together. She deserves an amazing amount of kudos. I want to thank Alpha Kappa Alpha Sorority Incorporated, my sorority, for all the chapters that came together, the NAACP, the Association of Black Women Physicians, Black Women Lawyers, so many people that care about our community. Thank you. We're going to do this again. We are going to be informed. You're going to know why you're making decisions. We're going to take care of each other. So with that, I want to say thank you to everyone and have a wonderful evening.
For those of you who are remaining, if you remain, we're going to have some raffle prizes, but you have to still be online to win. So you might want to hold off before you leave the conference. And so now I will ask my soror, Pavane Walters, to spin the wheel to see who's going to win. We will be emailing you your gifts. Pavane, can you spin the wheel? Our first winner is weddingchick@yahoo.com. We will be emailing you an Amazon gift card. And the next spin. Sybil at 1908, if you're still on, could you please put a note in the chat for us, please? And rghebre@gmail.com. If you're still on, could you send us a note in the chat, please? Did we get something from Sybil? Okay, Sybil is here. SSSWILLEY@gmail.com. Are you still on? I get a response, yes. So we have our 3 winners for today. Thank you for participating in the seminar, and we hope to see you next week.
On behalf of the partner organizations co-hosting this event, I would like to give special thanks to Dr. Valencia Walker for graciously serving as the moderator today. We also extend deep appreciation for our presenters, Dr. Olga Obi, Dr. Carol Wellaway, and Dr. Senta Georgia. Your presence today is a symbol of Black excellence in medicine, public health, and medical research. Information is power, and we are grateful for your expertise and knowledge because it gives us the tools we need to help our families and our community. For our attendees and guests, thank you again for joining us today.
Thank you so much for your remarks, Daria. Hello, everyone. My name is Dr. Natalie Natal, and I am the 22nd president of Theta Mu Omega chapter. I am so glad that you were able to take time from your day to join us for our very first webinar in our COVID-19 vaccine awareness series. Between the Tuskegee experiment and others, and combined with systemic issues of healthcare disparities that has been exacerbated by the pandemic, we know that we are dealing with decades of mistrust between the Black community and those in healthcare. And now more than ever, it is really important that we ensure that we are arming our communities with the right information from trusted experts in healthcare. So I encourage you to please consider the information that has been shared with you today by our amazing professionals and use this opportunity to educate others in our respective, in your respective communities. Now, as part of this series, we also want to highlight the role that HBCUs play in educating some of our nation's top STEM professionals, including many of those in medicine and research. They have been key in providing much needed information and services to our communities. So I want to take this time to acknowledge our very own moderator, Dr. Valencia Walker, a proud graduate of Florida A&M University. Great job today. Thank you. Transitioning into next week, I encourage you to join us for our next webinar series, Coronavirus, Myths versus Facts, that will take place on Saturday, February 20th at 2 p.m. Pacific Standard Time. While there is a lot of information available on coronavirus preventative measures and on the vaccine, there's a lot of misinformation that is being widely circulated amongst our communities. So with our special panel of medical experts, we will use this platform to dispel some of those myths and provide knowledge and wisdom from those that are actively working in the field. Now, before we part for this evening, I would be remiss if I didn't take a moment to thank our partners that were highly instrumental in bringing this series to you today. First, I want to acknowledge several Alpha Kappa Alpha Sorority Incorporated chapters. First, we have Alpha Alpha Nu Omega, Round Rock, Texas, Eta Pi Omega in El Paso, Texas, Mu Beta Omega in Inglewood, California, Omicron Eta Omega in St. Louis, Missouri, Sigma Pi Omega in Torrance, California, and of course, our very own Theta Mu Omega in Inglewood, California. I would also like to acknowledge Advancement of Blacks in Sports, the Association of Black Women's Physicians in Los Angeles, Black Women's Lawyers Association in Los Angeles, the Charles R. Drew Medical Society in Los Angeles, the NAACP chapter in El Paso, Texas, and the NAACP chapter in St. Louis, Missouri. We also have National Panhellenic Council in El Paso, Texas, the El Paso, Texas chapter of the Links Incorporated, Top Ladies of Distinction Incorporated, El Paso, Texas, and the Untouchable Academy in Los Angeles, California. Thank you all so much for your support. And finally, I would like to remind you that upon conclusion of this webinar, there will be a link to a survey for you to fill out if you didn't have an opportunity to complete during the webinar. We really look forward to receiving your feedback. On behalf of Theta Mu Omega chapter of Alpha Kappa Alpha Sorority Incorporated, we thank you so much for joining us this evening. We look forward to seeing you next week. Thank you for watching. Stay safe, wear a mask, and have a wonderful evening. Thank you. Bye-bye.